Good morning, everyone. My name is Meng. I'm the CEO of Entangled Query. I'm also a quantum developer. Let me tell you what a typical day looks like for quantum developer. Every morning, you open your laptop, start coding quantum algorithms, then you get stuck on a problem like this. Your first instinct is to Google the problem. That's how things should be. However, quantum developers don't have this luxury. Every time we Google, we can only find papers and documentations. Nothing directly solves our question. Then you will spend hours stretching your head without any progress. It really slows down the innovation of quantum computing. What is wrong with this process? On one hand, current discussion forums can be easily reached through Google, but the quantum community is not gathered there. On the other hand, a lot of discussions are happening in private channels, but you cannot access those knowledge from the outside. On top of that, they all share two common pitfalls. First, there's no quantum native experience. That's why you can see people posting photos of their circuit. Second, delivering high quality content and answering questions is time consuming. They don't provide any incentives for it. That's why we are building Entangled Query. To provide better user experience for quantum community, we offer a quantum native toolkit. To properly incentivize the community, we organize our community in a decentralized way. With our quantum native editor, you will be able to drag and paste just like talking to your colleagues face to face. Also, you can convert your circuit with your code, simulate and visualize the result. We also provide a search engine optimized for quantum terms. But the toolkit is not enough. We also need a strong community. To do so, we need to properly incentivize users. If they contribute high quality content, they will receive rewards, which unlocks more benefits. However, we are still one step away from the ideal community, because we need to give the governance and the ownership back to the community so they can have a say in the future of this community and truly be part of it. We are in a faster growing market. There are 600,000 Qiskit developers right now. With a huge growing momentum, there will be 1 million quantum developers by the end of 2022. Those developers' needs are underserved. Right now, there are 27 million software developers in the world. When quantum revolution happens, many software developers will become quantum developers. Data scientists will become quantum data scientists. And we can imagine more. Based on statistics, 80% of the developers use knowledge sharing platform every day. This is going to be the winner-take-all market, and we will dominate the landscape. That's why we will see a huge traffic in the future. With large traffic, sticky user, we will be able to capture the frontier of quantum industry. Then we will monetize our platform through sponsored content to promote quantum software hardware companies, hiring and events informations. To achieve our vision, we need to invest in development, community, and marketing. We are raising 1.5 million to help us reach the next milestone, to support us building the largest quantum community in this world. We have a strong team with a diverse background. I am a quantum developer. I have connection at every corner in quantum ecosystem. Siyu has extensive experience in software development. Jiaxin is an experienced product manager. And Victor is an active community lead in quantum computing. We also have a strong advisory board with Yanni from QCware and Eric from DoraHacks. Our website is live now. There are a lot of discussions happening. We have users from all around the world. And we are partnered with UC Berkeley and the University of Virginia. We are supported by the grant from Dora Factory. Thank you very much.
Do we have any questions? 1 minute.
Hi, you said you had a quantum-specific search engine. What does that mean?
So with more data we can gather, so we will be able to optimize the search engine based on NLP model. At the same time, because we provide a quantum native toolkit, so you will be able to search the circuit from our search engine.
Yeah, why wouldn't at some point Stack Overflow just have a channel on Quantum versus Entangled query as a completely separate offering?
So right now, the commitment of Stack Overflow and the Entangled query to quantum community is completely different. We are at the next level. At the same time, we are truly giving the ownership of our community. And with the traditional Stack Overflow platform, it's really hard to bootstrap the community discussion, especially in this quantum technology. So that's why we are adopting a decentralized way to organize our community, to bootstrap the community discussion and bootstrap the network effect.
I think if we don't have any more questions, we'll go on to the next speaker. Sorry.
Hi everyone, my name is Andri, founder and CEO of Nixlab. I have a PhD in electrical and information engineering and photonics and electronics, and have experienced more than 5 years working in semiconductor industry in South Korea, and work at IBM Watson at Silicon Nanophotonics team. Nixlab, a fabless chip company developing a future optical solution for quantum AI and data centers. So in 2021, Moore's law dramatically slowing. We know that the processor now performance 2 times improvement in 20 years compared to in the 90s that the performance improved every 18 months. So the complex problem in the classical computer cannot be solved with this classical computer. And then quantum computing enabled this new solution for this difficult problem. So the initial problem was come when I was doing my PhD research. I was working with the quantum entanglement chip, where I tried to control photonic entanglement chip. However, controlling light is a non-trivial process, requiring precision and smart control. And processing in quantum also time-consuming for AI training, for example, and demand fast timing and execution. Nixlab provides integrated quantum control circuit solution that enable users integrated their solution with the whole full stack system. So we provide hardware and software to the customers. And this is our product roadmap. We have a first product validation where we sell to the customers based on the hardware and software API. And the second step is developing these electronics with the FPGAs and also the photonic integrated circuits. These second steps not only enable the customers' feedback development, but also enabling new feature development with the customers. And the third part, the future product, will be the integrated circuits between the electronics and photonics. And this will enable many applications for a future need. The market opportunity itself growing. We know the photonic IC market in a global scale is around $36 billion. This supercharged the quantum AI and also data centers applications. And meet our team. We have extensive experience team members. Myself have been 10 years, more than 10 years in R&D experience. And we have Dr. Simon Poole in our advisor also. He is a serial entrepreneur with several startups and acquired by Finisar. And also we have Dr. Jonathan Fensky, the MD director, who successfully building a startup and sold to IBM. And we have currently 9 full-time members, mostly the electrical engineers background. And this is the industry landscape. In the industry, in quantum control, we know that there are startup growing in funding. Quantum Machine has just raised 73 million, and Q-Control has raised 44 million. This is our traction so far in the last 2 years. We grow a lot, and we just granted utility patents in September. We obtained 2 master chip designer, getting new inquiry, including Intel, and additional patents submitted, and we got also chip foundry contract signed, and we got exclusive deal with our sensor supplier. And we raised seed funding for our future milestone. This will be our target for the milestone, which is to deploy chip scale solution in Q4 2022 and continue to create leading IP, expand office in Silicon Valley to deliver current offering profitably and route to future growth. Thank you.
We have time for a couple of questions.
For your customers, are you confined to photonic-based systems?
Yes, for now, we have several customers, including NVIDIA, Fujitsu, for example, in data centers, and we also have customers in not only in quantum photonics but also superconducting computer field that use our product.
Time for one.
Do you design your own chip?
Yes, so we design our own chip. We have 5 chip designer currently in the team.
Let's thank Andri and invite the next speaker.
Hi. First of all, thank you so much for waking up so early and being here. My name is Kanav, and I'm super excited to tell you about qBraid. Before I do that, I'd like to begin by telling you the annoying experience that quantum developers go through today. Before you could even write the first line of your code, you have to install a bunch of classical code that, depending on the mood of the programming gods and a level of your expertise, could take you from a couple of hours to a week sometimes. And then once with the classical setup ready, you choose your device and language, you write your algorithms and circuits, run on a simulator or a device, and get the results. This classical stack has absolutely nothing to do with the quantum stack, and it's purely an overhead. And this leads to a lot of problem. The learning curve associated with the quantum computing already being so steep, having more requirements on the classical side just makes it super worse. And you would think that the classical software being developed over the past decades, this would be much more reliable, but it breaks all the time. In fact, during my PhD, I would spend a week or 2 every couple of months fixing all the bugs that showed up. And this is where I realized if the field is going to grow exponentially in the coming years, this cannot be the experience. I mean, people who are the smartest and sharpest minds in the world shouldn't be spending time on classical software, which should be figured out by this point. And people who are getting paid such hefty salaries shouldn't be spending time on things that could be automated. And this is what we've done. We've took the classical stack, this part, made it more robust, and put it on cloud. We've created a cloud-based integrated development environment, which is highly optimized for quantum computing. We dramatically reduce the time it takes for getting started in quantum. We provide you the perfect experience for quantum software developers. Let me tell you about our quantum stack. The principle we followed there was to get you the most out of the quantum today. We worked really hard to put the entire quantum ecosystem at your fingertips. Qiskit, Cert, Bracket, Pennylame, you name it, no installation, no hassle, and pure development nirvana. Right in the SDK of your choice, run it on any hardware. We already support many hardware with more coming soon. In the coming weeks, we will also be releasing qBraid SDK, with which you can write once and run on hardware of your choice. Better yet, pick any software development kit of your liking, and we will transpile your code on the fly and run it on the hardware of your choice. So far, we've had 3,000 users who've put our product in its paces at the world's top quantum computing hackathons and workshops. Multiple professors have used qBraid for teaching software development classes. And it's not just the academia. We led a project on quantum simulation with MathWorks earlier this year. We presented at some of the largest financial institutions in the world. Moving to the coming years, we're very excited about what's to come. Next year, we're aiming to reach 10,000 users on our platform, and we plan to release a bunch of new features for our platform, as well as new features for the qBraid SDK. In the following years, we plan to release quantum software, which will be application focused for machine learning, finance, and optimization. And what we're doing, we believe we're building a pipeline for tomorrow's quantum market. And we're projecting a TAM of $13.2 billion, SAM of 6.6, and a SOM of $66 million. And these numbers have come from the estimates taken from the BCG report. We will follow a software subscription model where the software will be available as a subscription, and we will have plans for academia and enterprise, as well as pay-as-you-go model for hardware access. We have a stellar team, which is a happy mix of quantum computing PhDs as well as software engineers. Moving forward, we're raising money for our seed round to accelerate the product roadmap, as well as hire the most brilliant people to build the most cutting-edge applications. Thank you very much for your time.
Time.
Is any aspect of your SDK open source?
Right now, no. In the future, we might make it open source. So I think the software needs to be in certain shape before it could be released as an open source. It's the same strategy for all of the.
One more question.
Is there any degraded performance by going through your platform versus native access to the frameworks?
That's a brilliant question. And that's where we focus our energy, making sure there isn't. We will include, for example, even for the transpilation.
Oh, you want to talk in the mic?
Yeah, sure. So even for the transpilation that we do, we plan to include PyTKet, which is by CQC, and which is one of the most amazing software there for optimization. So that means once we transpile, we would be sure by CQC that the transpilation is optimal.
I think that's all the time we have for questions. Let's thank Kanav.
So thank you very much for the invitation to be here today and to be speaking so early in the morning with such a nice large crowd. I'm Noel Goddard. I am the CEO of Qnect. We are a hardware company in quantum communications, and we are building the devices to enable the quantum internet. So what you may or may not know, since this is a very computing heavy conference, right, is that the race to develop quantum networking has already started. And in fact, there's a very large landmark study that the Chinese put out in early 2021 showing a 4,600 kilometer network connecting both satellite and ground nodes across their country, demonstrating that QKD could be done at scale. And we're starting to see other demonstrations now, such as the Delft-Hague demonstration that happened for MDI QKD this past summer. That was sponsored by both the private sector and the public sector, because these projects require large amounts of infrastructure as well as funding. And now there's some more recent announcements as you're starting to see private companies working together to try to make this space work. For instance, BT and Toshiba have recently announced that they're going to be building a quantum secure network across London. So it's a very exciting time. But if it's so easy, why isn't everyone doing it? Of course, there's plenty of challenges. And first and foremost is the fact that the devices in order to enable the next step have not yet been developed. So what we're seeing right now is first generation quantum key distribution. That's a point-to-point communications protocol. In order to make it longer, you either need to relay it, which is what the Chinese network has been doing through something called trusted nodes, or you actually need to be able to build something that provides quantum advantage in the communication space. And that's what we do at Qnect. We're building quantum repeaters. And when those are built, then you actually have to be able to support protocols, and the protocols themselves also need to be coming together in order to handle error correction, et cetera. So at Qnect, what we focus on a lot are real engineering problems. We want all of our devices to be compatible with existing infrastructure because they aren't going to lay an entirely new fiber bed across the world in order to make communications work. Scalability is a big thing for us in our designs. None of our equipment requires cryogenics or high vacuum. So everything we build is meant to be scalable, and that helps us to be robust so you can actually put these things in fiber hubs. And if all that comes together, then we can actually get over those distance limitations and architectural constraints. So our vision is to build the world's first quantum repeater product suite. Our differentiation is that room temperature operation and design. We are designed to be remotely deployed in fiber hubs. And the devices themselves all come in this packaging, which you're seeing there, which are standard fiber rack drawers. So we have a growing IP portfolio. We're the first company, we're very proud to say, to commercialize a quantum memory, which we just released the press release a few weeks ago. And we have first generation prototypes of other parts of our suite, which are right now supporting various experiments on the Stony Brook University Brookhaven National Lab fiber bed. So our product suite consists of 6 devices. 2 are necessary for doing quantum entanglement protocols, this protocol called entanglement swapping. It requires a quantum memory and a quantum entanglement source. We have a very special quantum entanglement source, which is coming together right now, which is bichromatic. That actually is going to be the basis of also being able to communicate with other devices like quantum computers. The quantum memory I just mentioned was just recently commercialized. And then we have all of these other devices which are necessary to either patch our devices to the internet itself or to each other. That's the baby picture of the beta version of the quantum memories. So we're very proud that that's actually pictures taken at Brookhaven National Lab. The fidelity right now is over 95%, and we're able to have coherence times up in the hundreds of microseconds. The communications market is still a little bit speculative, but again, it's going to be dominated whenever it grows by telecom, government, and defense applications. There'll be, of course, data storage and finance and critical infrastructure in that too. We see this as a huge opportunity in this time to be able to actually get early adopters and establish some market exclusivity by getting our devices out there first as first movers. We are raising money, like everyone. The idea is to hopefully raise 10 million over the next half year or so. What it will support, this is the edge of, I thought it was behind me, this is the edge of Brooklyn. So there are these coastal economic development regions which have been started up in Brooklyn in the last couple of years. We want to build a 5-node network in order to show that we can actually do entanglement swapping on real fibers connecting those nodes. We obviously need to scale our manufacturing, hire our software and network engineering teams, and then we're also going to start tackling the problem of trying to connect quantum computers to our network itself. And those entanglement sources I mentioned, stay tuned. They're the key to all of that. So there's my brilliant team. We're extremely proud of what we've managed to accomplish in just 1 year because we all got together post-pandemic to make all of this stuff happen. And thank you so much to all of our sponsors. We've been blessed by a number of federal grants which support our research, as well as both a seed round, et cetera. I was trying to keep my own time too. Thank you. Thank you so much for your attention.
Do you have any questions? Go ahead.
How much do you plan to charge or sell your quantum memories for?
So the quantum memories currently go for, it's like bargain price, if you do that now. So for academic and government customers, we've been selling them for $108,000, but that price should come down a lot. The reason that it's high right now is largely due to the fact that it's nothing is optimized in terms of supply chain. There's a very large margin on that right now. Yeah.
So why bichromatic and not temporal or some other representation if you're at 1550?
So right now, actually, the bichromatic wavelengths, which we have, one's in the O band, so 1324, and the other one is 795, which is optimal for the memory. So in the structure of the devices necessary to support entanglement swapping, our idea is that the memory is actually going to sit in the same node as the entanglement source. So you create the pair, you store one, and you send one. So it's basically one telecom photon and one memory photon. And we could do this, I mean, again, if you start talking about things like ion computing, right? The idea is that we could do another bichromatic source, which could do one at the computing wavelength and one at the memory wavelength or at a telecom frequency.
And is the memory fiber-based?
It's fiber-based in terms of the input and output, but the interior is free space optics. So I mean, it'd be nice if we can get it to the point of waveguides, but you can see a lot of, I keep thinking it's behind me. You can see a lot of mirrors and other things in the open box. So. Yes, thank you.
Thanks, Noel.
Thank you.
All right, good morning, everyone. Nice to meet you all. My name is Pranav Gokhale, and I'm the co-founder and CEO of Supertech. And our mission is to accelerate quantum computing. And I think we're all here because we think that quantum computing is at a very exciting time. But there's also this frank reality that there's a big gap between the hardware and quality and number of qubits versus the number and quality that we need to run breakthrough applications like molecular modeling. And it seems that at the current rate of progress, there's several years before we can run the applications that we envision. The mission of Supertech is to bridge this gap with something that we call cross-layer optimization. And this is a software technology that was developed during my PhD research. And the core of the technology is this realization that the existing software stacks for quantum computing are broken. And the reason is that the top of the stack is very digital. But the bottom of a quantum stack, unlike a classical stack, is very analog. It's waveforms and pulses. And in order to get from the top to the bottom of the stack, there's this massive inefficiency loss because the subtraction barrier principle on the left-hand side means that all these translations incur 2 to 3x efficiency losses. By the time you get down to the pulse, there's 30x to 100x efficiency losses. Now, my PhD research with my co-founder, Professor Fred Chong, was about developing software that goes directly from the applications down to the analog pulses that actually drive software. And we've been able to patent this through Chicago and also have trade secrets. And the value proposition here is that ultimately we can accelerate the utilization of the underlying hardware to effectively create quantum computers that are 5 years more mature than they otherwise would be. But again, done through software. So that's the technology. In terms of getting this product to market, we've developed this SuperStack platform. And there's a number of key features that enable it to be used by customer hands today. And a couple of them to highlight. First is that we're agnostic to both language and hardware platform. On the language side, we have open source front ends for Cirq and Qiskit and an open API. On the hardware side, we work with all the major quantum hardware vendors and have very good relationships with them. And this has been effective customer positioning because it means that customers don't have to build just for one quantum hardware platform. They can address them all at once. We've also designed our system to be very application-centric. These are real screenshots from our API. And it enables developers in fields like logistics, finance, and energy. This is a real example from a partnership with ComEd Exelon to experience and explore quantum speedups without ever needing to know a thing about quantum mechanics. So everything that I've just discussed is not a mere hypothetical, but we actually launched this in beta in August. And the left-hand side is our open API, which you can find at superstack.super.tech. And I'm happy to say that our publicly announced early adopters include research labs like Argonne National Lab and Berkeley Lab, as well as big companies like Morningstar. This is a nice testimonial from the director of Berkeley's quantum testbed, who is using our software stack to optimize the actual performance of their machine. It's the first place I think we truly have product market fit because they can't get the same performance out of their hardware unless they have our software stack. So where are we going next? We've already raised $500K as a pre-seed safe, but we actually haven't even touched a penny of it yet. And that's because we've been fortunate to receive over $1 million in government grants and early revenue. But we know that in order to be a winner in the space, we need to hire the top talent and continue hiring the top talent, which is why we're raising a $3 to $5 million seed round in the first quarter of next year. And this is entirely going to be about hiring 10 to 15 software engineers who are top in the quantum field. The team that we've built already has the expertise to bridge our quantum vision to reality. The thing I'll say about myself is that my PhD from UChicago Computer Science was the fastest ever in the program's history in 3 years. And we're bringing that same speed and agility to what we're doing at Supertech. The whole company was launched a year ago after I defended my PhD, and everything we've done has been in that year. My co-founder is Professor Fred Chong, who's a pioneer in the field and is the director of the NSF's largest ever investment in quantum computer science. And together we've hired a team of amazing researchers and developers, including 5 PhDs in quantum, as well as several people with software development experience. that's Supertech. Our vision is going to close the gap to practical applications. We have user traction and unfair advantages through premier partners like Duality. Thank you.
Time for a couple of questions. Go ahead.
What's a KPI you would use to quantify how much more efficiency or gain you can get from this hardware using your software stack?
Essentially the increase in program fidelity or program success rate. And so a couple examples of this, I see someone from IBM who we work with. We currently have the top ranking swap gate for IBM systems, and we've demonstrated 2x improvements in performance in their systems. On the Berkeley testbed, we have a paper that they just put out showing 60% gains in performance using our software stack. So essentially just percent increase in success.
So for the existing problem you're solving, I can see the problem quite clearly, but how about in the future? Is this still going to be a problem once all these different quantum computing create their own field standards?
Right. I think at some point it will become sort of a optimization is the root of all evil kind of phase. And I think in 30 years, it won't matter so much to have abstraction barriers to make things easy. But today we're confident that it's just about whoever's first to get quantum advantage, and that's going to require these advantages. I think as the field matures, our advantage will also persist because of customer traction and adoption. But I think there will always be a market for making quantum computers do something that other quantum computers can't.
Yeah, so in the classical computing market, there's no companies that were, especially in the 80s, there were a lot of companies that were doing optimizers, compilers, and had the exact same thing. None of them survived, and they all got subsumed by hardware companies. So what makes you think that yours is survive?
I maybe challenge the premise a little bit. In some ways, I'd describe Microsoft as one of those companies. And I guess one thing I can mention is that we are very eager to partner with hardware companies, and that's where we see a lot of sales happening. There's a big demand for these software optimizations from the hardware companies.
Thank you very much. My name is David Mitlyng. I am the co-founder of Xeros, and we're building a global timing service to replace timing from GPS through the magic of entanglement. On January 26, 2016, networks around the world started to fail. Fire and rescue radios went down, BBC digital radio went down, and even power grids started to fail, all because of a 13 microsecond error in the timing on one of the GPS satellites. Now, when people think of GPS, they think of maps, but in reality, over half the $1.4 trillion in economic benefit provided by GPS is as a timekeeper for the world. Every cell tower, every office building, every bank, every ATM, every data center has a GPS receiver on the roof specifically to get that timing signal necessary for that network to operate. And like that date suggests, if it doesn't work, the network goes down. But GPS was not built for this. It was never intended for civilian use. It is not secure or accurate enough. Enter Xeros. In 2018, my co-founder invented quantum clock synchronization using off-the-shelf QKD hardware to get very secure and very accurate time transfer between Alice and Bob. With that technology that we own outright, we're going to build a global timing service to replace timing from GPS that is 1,000 times more accurate and secure and 100 times cheaper. Part of the reason it'll be cheaper is because we only need one satellite to provide the timing. And the other part of the reason it'll be cheaper also too is we don't need to have exquisite atomic clocks in the ground terminals, in the boxes. The current paradigm today is there are tens of millions of units that are installed around the world. They average in price roughly about $5,000 per box. We put up one satellite and we'll offer this as a subscription model. We'll work with the hardware partners, have it installed at these sites to replace the timing units from GPS and charge subscription. It'll be $500 a month to start based off of better accuracy and security than today. And then we can upsell better security and accuracy as we get more satellites on orbit. The market opportunity is huge. It's about $500 billion, and it cuts across a wide range of markets. We've already got a foot in the door with defense agencies, as well as some initial contracts with defense agencies, as well as data centers and power grids. And as we get satellites on orbit, we'll move into Industry 4.0 and telecommunications, especially as telecommunications goes from 5G to 6G. It's very scalable. We don't need a whole constellation of satellites to start. One satellite over North America provides timing synchronization over all networks across North America. And then we add additional satellites as we go into new markets and want to get better quality of service that we can upsell to get better revenue per site. By scaling up this way, we expect to achieve our global timing service and $100 million of revenue within 5 years. We'll be cash flow positive. But what will be more exciting is we'll have that minimum constellation in place that provides entanglement distribution and global timing at picosecond level accuracy. Because when you have that, you have the foundation for the quantum networks. A colleague at Qnect was talking about that. You also have timing accuracy necessary for gravity gradient sensors for mineral and oil exploration. We'll also have the timing necessary at cell towers that you could provide very accurate positioning over 5G for self-driving vehicles and IoT vehicles. And those are markets we want to own outright. We do have some competitive landscape. Timing and synchronization units are already fairly well established with companies like Microchip, IBM, and Ericsson, but they'd be our partners. We own the space segment, we license it, then they install it at their sites, use their sales channels. There's also some other startups that are doing positioning, GPS replacements, but they're focused on the position signal over RF. So they'll also be partners. My co-founder, he's the inventor of this technology. He's the brains operation. He has a lot of new IP that he's developing. And I'm the person who's going to build this. I have 30 years working in old space and new space. I built many, many satellites. I've sold satellites as business development, about $300 million, $750 million worth. So we have the right team. We have traction. We have contracts with the Air Force, NASA, Navy. We got research and collaboration agreements in place. We just finished the Techstar Space Accelerator. We're now in the CDL quantum stream. So we got the team, we have the IP, we have a big market we're going after. We're now seeking $1.5 million of seed funding to grow our team and facilities. I guess with that, I'll see if there's any questions. And I'll also note too that there's a investor kit on our website, xeros.com/investor kit if you want to learn more. Thank you.
Do you have any questions for Xairos?
Sorry, not a judge, but so to what extent is it going to be important for standards to be aligned with your technology in order for your full, applications to be realized?
Yeah, so the technology was invented by my co-founder, so there's no standard around that, but we were invited. We do recognize standards are important. We want to license this out and eventually, for all intents and purposes, give it away because we want to own, we're in a race to get that global timing service in place. So we were invited by JPL to do a presentation at the CCSDS conference. They got a timing synchronization standard. There's a timing standard being set up at ORAN, which is one of the 5G kind of networks. So yeah, we're very open to making this a open standard rather than trying to hold it in as a proprietary thing that we try to monetize. Like I said, our focus is really getting this system out there working with partners.
Why is your satellite less vulnerable than a GPS satellite to disruption?
Well, so obviously you've seen in the news the anti-satellite missile test. So our system will not be any less vulnerable to an anti-satellite missile. Let's just be honest. But the key thing for us is we're going to design our architecture with multiple satellites so that at the very least it's harder to take out all those satellites. If anybody's been following this in the news, there's a big movement within the US government to make a replacement from GPS. And the thought is that future GPS will be for military use only, and time synchronization and position will be privatized with companies like us. So to a certain extent, it kind of takes the target off the back of the GPS constellation. So this is being encouraged by the US government. I don't know if that makes sense. So.
Great. I think with that, we have come to the